Okay, so everyone, today I'll be doing the week 11 physics quiz. I'm joined with two very special guests, hala Saad and
Hey everyone.
another type of special guest, Majd Deeb.
Hey! Okay, bro. Okay, I saw this. I guess. Okay,
So,
bro. Okay.
question one: in order to test the rate of conduction inside different materials, three different conducting rods of the same dimensions with corks glued by wax at their ends are heated equally using a Bunsen burner, as shown in the figure below. Okay, this is the figure. The corks will fall off in different periods of time due to different rates of conduction. So basically, all you need to know here is the more conductive a material is, it's gonna fall. The cork will fall off the wax faster because the wax will melt, so the cork will fall. Now, obviously, you should know that copper is the most conductive because you use it in wires for its conductivity, and it's just an overall very conductive material. So you put that at first. Now, the fiberglass rod, the cork will fall off at last because it's the insulator. Steel is a conductor, so obviously it's gonna go second, and the fiberglass is the insulator, and it's gonna maintain your heat. It's gonna absorb it. It's gonna keep it, so it will melt last. So you match it to the third one. Okay, question two. Hala, would you like to explain or let I explain?
I still have like three questions left to
Thank you
explain.
so much. What are the factors on which the rate of conduction of heat depends? The poorer the conductor, the better it insulates, obviously, because the conductor is the opposite of an insulator. And the other way around, the poorer the insulator, the better the conductor. The thicker the insulator, the slower the rate of heat loss, obviously, because the insulator absorbs the heat, it keeps the heat in. And the higher
Oh.
the difference between temperature between two sources, the higher the heat loss. So, for example, if you have a substance at 100 degrees Celsius and you have another one at 2, it's gonna transfer at a faster rate as compared to like 55 degrees and 50. Then that would be slow because they're almost the same temperature. Basically, they're gonna try to reach equal temperatures, so it's gonna go at a faster rate, and eventually it's gonna slow down later at the end. Okay, question three. Underline the conditions that should be satisfied in insulation. Uh, Obviously, it has to be effective and it has to be cheap. I don't know what partial means. What is partial insulation? Indoor, kind of dumb because like what is indoor and manual? I don't even need to explain. Describe the heat transfer by convection. Okay, choose the correct answers to complete the sentence below. During convection, when a part of fluid sample is heated, it becomes less dense, so it floats upwards. Obviously, because density, the less dense it goes up, and the more dense it goes down. Okay, question five. Which of the following statements are true about heat transfer by radiation? Select all that apply. The energy lost by a body emitted in protons is called quanta. Quanta is basically packets of light. This is another definition of energy according to quantum theory. To the in the book, it's
Whoa.
called quanta. Yes, Majd, indeed. Whoa. Radiation can be defined as the flow of heat from one place to another by means of electromagnetic waves. Yeah, I don't really need to explain. And radiation from hot bodies can transfer through empty space, can travel through empty space. Sorry, think of the energy from the sun to us. It travels by radiation, obviously traveling through empty space, which is vacuum. Okay, question six. Thank you so much, Majd. Conduction is the flow of heat along matter without any flow of matter. Obviously, because your matter isn't moving. It's just the molecules and the particles inside. Okay, question seven. Which element is the poorest conductor of heat? Choose the answer. Now, you have in the options other conductors, and you have water and fiberglass. And they, for some reason, for me, they were put right next to each other, so like misclick. But keep in mind that water is poorer than fiberglass. Fiberglass will still conduct heat, but water won't as much. Water is a very bad conductor.
Another point, its water is the best insulator.
Exactly, which is the poorest conductor. Yeah, it's the same
Whoa.
point. Thank you so much. The states of matter that convection takes place are liquids and gas. You can say fluids. Don't say liquid. In a written, you can also say fluids. Okay, when a part of a fluid is heated, it becomes less dense, so it tends to float upwards. Okay, this is what they're explaining here is convection. Now, what you need to know, the result that the upward and downward lateral currents of fluid movement is called convection currents. So when you see currents, and this is describing convection, just join them together, convection currents. Okay, question 10. The experiment below is conducted to help visualize convection currents in air. The arrow pointing down shows cold air going to the box. Okay, you're heating, right? The heat will make the air rise up. It'll become less dense. It will go up. So then obviously it's gonna the if you have hot air up, the cold air will go down, will sink down. So just remember, when one goes up, the other goes down. The arrow pointing down shows cold air going into the box because this is the gas being heated. The smoke when above the lighted candle, it's the hot air. The one that's going down is the cold air. You don't even need to know about convection. Obviously, since it's under the candle, the hot air is gonna go up. So going down is the cold air, and going pointing up is the hot air. Okay, question 11. In figure 1, the hot air above the land rises and is replaced by cold air coming from the sea. The phenomena of air convection observed is called sea breeze. A simple trick to memorize it: whatever cold air you have, that's for example here it's the sea. Whatever it is, breeze. So here it's sea breeze. Cold air from land, land breeze. That's all you need
So
to know.
you have to look from where is the air coming. If it's coming from the direction of the sea, sea breeze. If it's coming from the direction of the land breeze. But in the end, they're both
That as
breeze
well,
types of
exactly.
breezes.
Also, yeah, look at the arrows here. The air is coming from the sea onto the land, and from the land onto the sea. Okay, question
Wow.
2, 12. Thank you, Mish. To stop convection, this is what I meant by special in another way. To stop
Okay, bro. Okay.
convection, insulators with many very small air bubbles are used. Because convection essentially is the passing of kinetic energy from the hot moving molecules to the cold slow moving molecules. So if you have air bubbles to fill the gaps between these molecules, the air won't transfer as much, or the
And
heat won't
another way
transfer as much.
is
Sorry, continue.
the more air bubbles you have, the better an insulator it is because convection cannot happen in small places. It has to happen over larger distances, meaning you need more air bubbles to get it less convection.
Okay,
Okay.
question 13. Max Planck. This is wrong, by the way, because if they ask you in a what's Planck's constant and you write Planck like this, they'll give you wrong.
Whoa.
It's Planck with a C like this. Max Planck came up with the idea that energy lost by hot black bodies is quantized. Okay. Uh, okay. Essentially, what quanta is, I told you, it's packets of light. Now, black bodies, they absorb the most light and they also radiate the most light. Or you'll see it in a later question. So the energy lost by it is light, essentially. So that's why we label it quantized. Now, the relation between the energy E of each quanta and the frequency F of radiation is represented by the equation E equals HF. Now I wrote in the blank here E equals HF, but they didn't mark it right. So just write HF if you have E equals given up there. Okay, question 14. The best absorber of radiant energy is a black body. This you have to know. Okay. Use Planck constant H equals 6.6 times 10 to the power of negative 34 joules per second. Choose the correct answer. The energy carried by the photon. Okay, you apply equals E equals HF. So H is 6.6 times 10 to the power of negative 34. So times 10 to the power of negative 34 times it's the frequency, which is 1.2 times 10 to the power of 15, which gives us 7.92 times 10 to the power of negative 19, or 7.9 times 10 to the power of negative 19. Okay, question 16. What does a thermocouple measure? Temperature, it's in the name, thermo. Which wires are made of the same material? uh, W and Y. And honestly, the way I know it is because if you can see here, these two wires have like the same thickness. Meanwhile, wire Z is a bit thicker than the other. But take it that way, and I think it's correct. Okay, what does meter X measure? Current. Now, the only meters we really took is the last year is the ammeter and the voltmeter, and I don't think voltage was there. But if it was, voltage wouldn't really make sense. So, what does meter X measure would be the current,
And
obviously.
by the way, meter X would be a galvanometer, not an ammeter. Even though it's measuring current, it's a galvanometer because they detect more specific types of current.
But by the way, I asked, and ammeters do work. Like they work, but they're not specific. But it works. What
Yeah, they work, but usually we use a galvanometer.
doesn't matter what you use right now because like you're not in a lab, so it
Mm.
doesn't really matter. It's pure theory, so it's fine.
Oh.
What statements correctly describe a thermocouple? They have low heat capacities and they have relatively high precision. So obviously it's not high heat capacities because we just said they have low heat capacities, and they can measure on a variable temperature, not high temperatures only. Thermocouples have slow response to temperature changes. Actually, not, they're very adaptive to the temperature. They can respond very quickly. Okay, question 17. By the kinetic molecular theory, that heat transfer by conduction occurs when faster moving molecules in the hotter parts of matter collide with the slower moving molecules in the colder part, thus passing on a part of their kinetic energy. I explained this briefly in like 3 questions ago. What conduction is the transfer of kinetic energy from the faster moving hotter parts of the substance to the slower moving colder parts, and this they collide with each other. So then in physics, you took this in chapter 9. It's going to transfer the energy, which is this is what it's basically saying. Question 18. What is one action that can be done to try to fit the solid sphere? The sphere cannot fit into the cylindrical hole. What you're going to want to do is cool it. Now you know that cooling shrinks and heating expands. So let's say they said the solid sphere is too small to fit into the cylindrical hole. You can say expand the solid sphere and then it will fit into the cylindrical hole. What statement best describes your answer in A? Cooling shrinks the sphere. Okay, question 9. How can you tell which metal is the best thermal conductor? The one that loses the match first, because somewhere here it said I think, yeah, wax. They have wax. So it's gonna be the first one to melt the wax. Whichever one melts the wax first is the fastest conductor, because that means heat is traveling the fastest through. The one that loses its match first, because the wax will melt it and the match will fall off. Okay, question 20, which is the last question. A heat radiator is placed between a white and black surface as shown below. Which surface is the better absorber of heat? Black surface, we said it. Which surface is the better reflector of heat? White surface. And which surface is the better emitter of heat? The black surface. Now, you should know this by like real life application. Normally, you tend to wear white shirts in the summer to cool you off, because if you wear black shirts, you're gonna absorb way more heat. You're gonna be warmer. And in the winter, you should tend to wear more black clothing to absorb your heat, to maintain your heat. So this, you don't even need to know this experiment pretty much, other than the last part, which is the best. Which surface is the better emitter of heat? The first two are real life practical applications. As for the third one, you can read the book and it explains it a bit. What I would do if I were you, I would memorize it, and honestly, it's common sense. And yeah, that's pretty much the entire quiz. Good luck, guys. I don't even know if you'll be here tomorrow, but if you are, I feel sorry for you.